Here we have a source. This source is emitting spherical wavefronts. We divide these wavefronts into two parts by placing two slits symmetrically. So you have placed two slits symmetrically like this. This is S1 and this is S2. S2. Now a part of wavefront is emerging from S1, another part is emerging from S2, and these two source of light S1 and S2, they are behaving like a coherent sources. ठीक है ना? They are behaving like a coherent sources. Now I am assuming that separation here between these two slits is small d. ठीक है? I am saying separation between two slits is small d. And we place a screen here at a distance d. So here at a distance d, we place a screen. So this is a screen, and separation between the slit plane and the screen is capital D. What you have to remember here, you have to remember this d is very, very large as compared to small d. ठीक है ना? This d is very, very large as compared to small d. Now, light waves, so I am saying like this, suppose light waves travel along this path and reach at this point P, and this P is at a distance x. So I'm doing next aspect of the Young's double slit experiment. So I'm assuming a point P, ठीक है ना, on the screen which is at a distance x, which is at a distance x from the center point of the screen. So at this point, light waves, they are reaching from source S1 as well as from source S2. They are reaching like this. So what will be the path difference between these light waves which are reaching at P? That path difference, delta, that will be S2P minus S1P. This will be the path difference. This is the path difference between the light rays which are starting at S1 and S2 and they are reaching at point P, and there they are interfering. They are producing interference, or you can say they are overlapping, and as a result of overlapping, there will be some intensity here. I want to find out the intensity at point P, which is at a distance x from the center. So if I provide you an arbitrary point P, which is at a distance x from the center, and you want to find out the intensity at point P, only this x is given to you, then how can you find out the intensity at this point? This is my objective. So my objective is very clear. I want to find out the intensity at an arbitrary point P, which is at a x distance from the center of the screen. So this is my objective here. So what I'm going to do here, at point P, this will be the path difference. What will be S2P? Try to understand what is S2P. This is S2P. So if I draw a perpendicular like this,
Sir,
yes, beta, please.
can you please tell that once more?
Okay, you can write, please. We want to find out the intensity. We want to find out the intensity at an arbitrary point P. At an arbitrary point P on the screen, we want to find out the intensity at an arbitrary point P on the screen, which is at a distance small x, which is at a distance small x from the center of the screen. From the center of the screen.
Arbitrary.
Which is at a distance small x. This is small x. Which is at a distance small x from the center of the screen O. From the center of the screen O, from this point. Now look, this is S2P. I want to find out this. So this distance is D. This distance is this. And this perpendicular distance, this is X. And how much is this? If this is d, this will be d by 2, this will be d by 2. So this distance, that will be equal to small d by 2. Because these two slits, they are symmetrically placed with respect to this axis, symmetrical axis. So this is d by 2, this is d by 2. So automatically this distance will also be d by 2. So what will be this S2P? This S2P you can write, this will be, this is S2P, so this will be square root, or I will write power 1 by 2. This will be capital D square plus x plus this is d by 2 whole square and square root of this. I'm using Pythagoras theorem, so hypotenuse square will be equal to this capital D square plus x plus d by 2 square. I'm using this one. ठीक है ना? I'm using this one. Now what will be S1P? This S1P. So for this purpose, I will draw a perpendicular here. I can use different color. So here from S1, I draw a perpendicular like this. This distance is again d by 2. This is d by 2. So what will be this distance here? This distance. This distance will be x minus d by 2. This is capital D. So from the Pythagoras theorem, what will be S1P? That will be square root of d square plus x minus d by 2 square. So this will be minus here d square plus x minus d by 2 and whole square to the power 1 by 2. This will be. Okay, now we have to solve it. Okay, so here I am using this condition. So here this d is this distance, this is in meter. Try to understand this will be in meter, and this is small d, this is in millimeter. Or so consider this is in millimeter, and this distance it will be in meters. So here if I take this d square common, then it will be like this. This will be d will be out. Here 1 plus x plus d by 2 whole square divided by capital D square to the power 1 by 2 minus again d square common. So this will be 1 plus x minus d by 2 whole square upon capital D square to the power 1 by 2 to the power 1 by 2. ठीक है ना? This will be. So apply the binomial expansion. ठीक है? Apply the binomial expansion here. Binomial theorem you apply. So this will be 1 plus x plus d by 2 whole square. So what is binomial expansion? If you are having 1 plus x to the power n, this will be 1 plus nx plus higher terms. ठीक है? Plus higher terms. So here this will be d square and 1 by 2, this 1 by 2, this n is 1 by 2 here, so this will be 2 here. And higher terms I am neglecting because this will be a very small quantity. This will be in millimeter, this will be in meter. So this quantity will be very, very small. This will be 1 meter, suppose. So this is 1 square, this will be 2 only. But here if this is in millimeter, 10 to the power minus 3 and square of that, that will be a very, very small quantity. So higher power of this I can neglect.
Sir,
Minus this will be d square 1 plus x minus d by 2 whole square upon 2 times d square. If you multiply, this is d, this will be d beta. This will be corrected. This will be d here. ठीक है ना? This will be d. So now this d into d, and here this will be minus d. So this term is going to cancel out. And here, if you multiply this d here, then 1d will cancel out. From here, 1d is going to cancel out. So you can take 1 by 2d out, 1 by 2d out, and inside it will be x plus d by 2 whole square minus this will be x minus d by 2 whole square. ठीक है ना? It will be like this. Now expand these squares. So if you expand these squares, then you will find out x square will cancel out, d by 2 whole square will cancel out, and you will be left with 1 by 2d. And from here, this will be 2 into x into d by 2. So this will be xd from here, and minus minus plus xd from here. So this will be 2 times xd. So 2 will cancel out. So here, this part difference delta, that will be x d by d, d by d. So this is a very important formula. Try to understand. Remember this formula always in Young's double slit experiment. So what this formula is telling me, if you are having an arbitrary point P, if you are having an arbitrary point P at a distance x from the center. So if x is given, then I can always find out the path difference at this point P. Try to understand, at an arbitrary point P, which is at a distance x from the center, what will be the path difference? Path difference will be x d by d. If they are providing you x, you can always find out delta, path difference. So what I'm saying, this delta is how much? This is x. ठीक है ना? Look here. So this is x into d by d. This will be d by d. So remember this formula. So this will be x and d by d. And if you know delta, try to understand. If you know delta, then you can always find out the phase difference delta. What will be phase difference delta? That will be 2 pi by lambda. And this will be delta here. Okay? So first you are going to calculate this path difference. From path difference, you can always find out phase difference. And when you know the phase difference at point P, I am writing here point P. And if you know the phase difference at this point P, then intensity will be how much? Intensity will be, okay, intensity will be how much? Square root of, so not square root, this will be A1 square plus A2 square plus 2 times A1, A2 and cos delta. ठीक है, cos delta. If A1 and A2 are equal, then it will be 4 A1 or whatever it is, A1 square cos square delta by 2. Cos square delta by 2. So in this 3-step, you can find out. First, use this formula to find out the path difference. From path difference, find out phase difference. From phase difference, you can find out the intensity. So in this way, at an arbitrary point, at any arbitrary point on the screen, okay, if you know the distance of that point from the center of the screen, then you can find out the intensity at that point. So most difficult question they can ask related to YDSC is this one. They will give you an arbitrary point and they will ask you, okay, find the intensity there. So you can find out. So you can find out intensity there. Is it clear up to this point?
Yes, sir.
Good. Now, from this formula, if you look at this formula, okay, what will be x? X, if I want to write x, x will be capital D by D into delta. Okay, this will be capital D by small d, and this will be delta. So this is the distance of a point from the center of the screen. Okay, so at what distance from the center of the screen you are going to get a maxima or minima? If you want to find out, okay, what will be the distance of nth maxima from the center of the screen, or what will be the distance of the of the nth minima from the center of the screen. If you want to find out, how can you find out? From this formula. From this formula. So condition for maxima is that for maxima, this delta will be equal to n lambda. This will be n lambda. So what it will be, you can write here that maxima, nth maxima you are going to get here, where part difference is n lambda, so this will be n lambda. So you can say this is the distance. This is the distance of nth maxima, nth interference maxima from the center of the screen. Now, if I ask you, okay, find the distance of n plus 1th maxima from the center of the screen, then okay, you will say that this n will be replaced by n plus 1. So this will be d by d. D by d, and this will be n plus 1 lambda. Now, what will be the separation between two successive maximas, n plus 1 and n? So separation between two successive maximas, that will be x n plus 1, n plus 1 minus xn. Okay? So this term will cancel out dd by lambda. So this term will cancel out, and what you are going to have, this is d lambda upon small d. And what is this? This is the separation between n plus 1th interference maxima and the nth maxima. What is this? This is the separation between nth and n plus 1th maxima. Are you seeing any n on the right hand side? No, there is no small n on the right hand side. It means this gap between two successive interference maximas, it is independent of the order n. It is not depending upon n. There is no small n on this side. It means if you choose any two successive maximas, interference maximas, this will be the separation between them. We represent this by beta, and this is equal to d lambda upon d. This will be beta. Later on, I will call it as fringe width. Right now, I am not saying this is the separation here. Here, I am saying that separation between two successive maximas is beta equal to capital D lambda by D. Capital D lambda by D. Now apply this equation to find the position of minimas. Now I want to find out the position of minimas. Okay. Okay. So what is the condition for minimas? Condition for interference minimas. ठीक है ना? Interference minimas. What was the condition? Condition was delta, and this was equal to n plus 1 by 2 lambda. And what was n? N was 0. So first minima you are going to get at lambda by 2, n equal to 1. Second minima is you are going to get when part difference is 3 by lambda, 3 lambda by 2, 5 lambda by 2, like this. So in this way you can say. So with this here, remember this, you are saying n equal to 0, but this is not 0th order minima. No. So always remember, it doesn't matter what you are using here. What matters is you are getting first minima here, second minima for the part difference 3 lambda by 2. So whatever formula you want to write, you can. But first minima, you will get where part difference is lambda by 2. Either you are using any formula, it doesn't matter. This is a mathematical expression. But you have to understand first minima you are going to get where this delta part difference is lambda by 2. Second minima you are going to get where part difference is 3 lambda by 2. So this is first order minimum. First order, this is second order minimum. This is third order. It is like this. Now, what will the position of any? I'm writing this is actually what one? This is if you are writing 0, 0. So this is actually n plus 1th. If you look at this is n plus 1th minima, order minima. So just I'm writing, I'm not going into the order, you know it. I'm writing delta n is suppose this n plus 1 by 2 lambda. So corresponding position, its position corresponding to this part difference is suppose xn, and this will be d by d, d by d. And here delta, so in place of delta, I will write n plus 1 by 2 lambda. 1 by 2 lambda. Next minima to this, next order minima, that I'm writing it as n plus 1, n plus 1. And if you write it more, then it will be, try to understand when you are getting 0, that is the first order minima. When you are writing 1, that is second order. So if you are, please don't confuse. If you are writing n, this will be n plus 1. Okay? N plus 1. Okay? So don't confuse. Okay? N plus 1 I am writing here. Hopefully you are understanding. Next is n plus 2. This is next order. I'm not interested in order. I'm interested in the next order minimum. So this will be here in place of n, increase it 1 by 1. So this will be n plus 1 here. So this will become n plus 3 by 2. 3 by 2 lambda. Okay, so you are increasing n by 1. So increase here n by 1. So this will be n plus 3 by 2. So what is the gap between these two successive minimas? Xn plus 2 minus xn plus 1. And what you find out? You find out that this is also equal to d lambda by small d. And that was the gap between the two successive maximas. And here, the same gap, exactly same gap you are getting for two successive minimas. What is the meaning? So if you are having this type of screen and you are having a two minimas like this, try to understand. Suppose I'm saying this is n plus 1 and this is n plus 2. So what you should say about this gap? See, what should you say that what is this? I have denoted it by red line. This is the gap you are calculating here. And what is this? This is the width of this fringe. This is the width of this fringe. Okay, here this maxima is surrounded by two minimas. So this maxima is expanded from this minima to this minima. So separation between two successive minimas, this is called as fringe width. So what you are going to call it? You're going to call it fringe width. Fringe width. So what is fringe width? Fringe width is the separation between two successive minimas which are surrounding a maxima. Two successive minimas, they are surrounding a maxima. So separation between them is called as fringe width. So this is called as beta. We call it as beta. So what will be beta? That will be d lambda upon small d. That will be d lambda upon small d. This will be. So this is called as fringe width beta. Okay, that's why you are saying it as fringe width. One thing is this. Now come back here. Okay, let it be like this. I'm drawing this is our source S. We are drawing a symmetrical line. Here we are having slit S1 and then S2 is here. This is S1, this is S2. Okay? and here we are having a screen. Okay, we are having a screen here. So this is a screen and this is the center of the screen. So if you want to, if you suppose you are saying that here you are getting 7th order maxima, okay, 7th order maxima, or simply I can write, suppose this is first order maxima, okay, you are going to first order maxima. You are saying this is n equal to 1. So what you will say that this is beta. If you are here, you are having n equal to 2 second order, then this will be 2 beta. Okay, this distance is 2 beta, try to understand. This is beta, this is 2 beta. If you are having here n equal to 3, then this distance from here to here, this will be 3 beta. And if you are having this as n equal to 4, then this will be 4 beta. So try to understand. Now you are going to think in this way. So what is the separation from the center to the nth order, to the nth order maxima? That will be n beta. If they are saying that, okay, this is here, this is first order minima. Okay, another minima will be here. So what is the separation between this O and this? This will be just beta by 2. Try to understand. This is first order minima. If here you are having second order minima, so this will be 3 beta by 2. You are going to think in this way, then this is third order, then this will be 5 beta by 2. It is like this. And it will make calculations very easy. It will make calculations very easy. So in this way, you are going to think now in terms of beta. Beta is called as fringe width. One more thing. What will happen to the fringe width? ठीक है ना? If we dip this apparatus, YDSCX apparatus in the water or in any liquid whose refractive index is mu. So try to understand, if we place YDSC experiment then what will happen to fringe width? To fringe width. Width beta. बोलो बेटा. बोलिए please. So try to understand very simply. Suppose this is first medium, air. So what is the refractive index of air? You can say mu A, that is 1. And this is another medium and its refractive index is mu. And light waves, they are traveling from here to the second medium. Okay? Second medium. So which quantity will remain same when light moves from first medium to the second medium? Please tell me.
Frequency, sir.
That will be frequency beta. So frequency is going to be same here and here. Okay? What will be the speed of here? What will be the speed of this light? That will be c. That will be c. So this will be, here you can write speed is c. Speed is c. And here this will be v. Okay? This will be v. And what will happen to the lambda? Lambda is, suppose here this is lambda. What will happen to the lambda here? Here lambda will become lambda by mu. Lambda by mu. Okay? So remember, this c will convert into v. Frequency will be this. Lambda will change from lambda to lambda by mu. Look here. What is the formula for this? This will be C equal to this will be nu lambda. In a very simple way, I am telling you. What will be lambda here? So formula will be same here. This will be V. V will be, this will be nu, and this will be lambda. You can say lambda prime. Lambda prime. What will be V when light moves from one medium to another medium? From the definition of mu, you know that this will be C upon mu. So this will be nu here. So if you want to satisfy this equation, how can you find out? If I divide it by this mu, automatically you have to divide this by mu. So this will be lambda upon mu. So in this simple manner, you can do this calculation, or in any way you want. So when light travels from air to a medium, its velocity is changed, and new velocity will be c by mu, and wavelength it will be lambda by mu. So what I am saying here, when you are placing this YDSC experiment in the water, then lambda, ठीक है ना, lambda will become lambda prime, and it will be lambda upon mu. ठीक है, lambda upon mu. So what will be beta prime, nu beta prime? Capital D is not going to change. This lambda, I just write here first lambda prime, and this will be small d. So this will be d lambda upon mu divided by small d. So beta prime, this will be 1 upon mu, and d lambda upon small d. And this was beta. So nu beta prime, when you have placed this Young's double slit experiment in the water, and you're looking from the outside, then this beta prime will appear to you as beta by mu. This will appear to you as beta by mu. This will be, ठीक है ना, this will be beta. Is it clear what I'm saying? So when you are placing this Young's double slit experiment, suppose there is a tub or something, and you place that experiment inside the tub, water tub, then you will find out that beta will appear as beta prime. ठीक है ना, and beta prime will be beta upon mu. So fringe width will be reduced by a factor of 1 by mu. Is it clear to everyone?
Yes, sir.
Yes,
Good.
sir.
Another important thing, that is optical path. Another is optical path. So optical path will be equal to refractive index of the medium mu and whatever distance is in air. ठीक है ना, whatever is distance in the air. So suppose there is a medium here. This is a medium, some medium whose width is d. So this is some medium. So what is the optical path from here to here? So optical path from here to here, that is equal to mu into d. Mu into d, if mu is refractive index of this medium. What is mu? Mu is refractive index of the medium. So what is optical path? Optical path is equal to mu into d. ठीक है? This will be refractive index of the medium. Refractive index of the medium multiplied by distance. distance. This is optical path. ठीक है, optical path. So optical path is mu into d. ठीक है ना, this is mu into d. Now I'm telling you one very simple question. Suppose I am drawing two lines. ठीक है ना, I draw these two lines. Separation between these two lines is small t, and in between these two, air is filled. Between these two lines, what is the medium? Medium is air. So what type of medium is here? That is air. And refractive index of the air is equal to 1. So if light waves travels from here to here, how much optical path will be traveled by the light? So optical path here, ठीक है ना, I write it as 1 optical path, OP1 optical path 1, this will be 1, refractive index is 1 into thickness T, so this will be equal to T. ठीक है, this is. Now, in between same two lines are exactly same. Thickness is T, but in between them, I placed I placed glass. Suppose I filled the glass here, or I filled a medium or glass. It's better to consider it as glass. And refractive index of this glass, this is glass, and this is its refractive index is mu. ठीक है? Now light waves travels from here to here like this. So what is the optical path that will be traveled by the light here? That will be refractive index is mu, and that is T. So due to the introduction of glass plate, here this was air of thickness T, and if this space is filled by glass, ठीक है, if this space of thickness T is filled by a glass, then what is the change in optical path? ठीक है, what will be the change in optical path? What is the extra path introduced by this glass plate, you can say? So extra optical path introduced by the glass plate of thickness T of thickness T and refractive index mu. Index mu, it will be how much? This will be equal to, this will be this mu T. This was later after introducing glass plate. This is the optical path, and this was the earlier optical path. So this will be equal to difference of these two, mu minus 1 into T. So a glass plate will introduce an extra optical path equal to mu minus 1T. So this will be the extra path introduced by the glass plate. ठीक है, so whenever you are introducing a glass plate, this will be the extra path that is introduced by the glass plate. So now come to the Young's double slit experiment. Here
One second, please.
Yes, beta, please.
1 second, last previous.
Okay, beta. Can I go to next?
Yes, sir.
Now, this is my Young's double slit experiment. So this is S1 slit, this is S2, they are acting as coherent sources S1 and S2. ठीक है? And here is the screen. Here we have placed the screen. So what you have done here, you have introduced a glass plate here. So what you are doing, you are just introducing a glass plate here. ठीक है? In front of the slit S1. So you placed a glass plate or mica sheet in place of in front of the slit S1. Its thickness is T, refractive index is mu. So what will happen here? Light is traveling towards the screen, but in this journey it is passing through this glass plate. Glass plate is thin, or thickness is T here. And it is like this. Thin is, it is not thin, it may be of thickness T. So this will be, and this point is P. ठीक है ना? They are meeting here. Now how much path is traveled by this second one? That is S2P. So what is the path difference? Path difference is S2P minus, what is the path length that is traveled by this? Earlier it was traveling S1P. Understand? Before introducing glass plate, it was traveling this distance in the air. Light was traveling this distance in the air, but you have introduced this glass plate of thickness T. So how much extra path will be introduced by this glass plate? This will be mu minus 1 into T. This is the extra path length that is introduced by this. So this is delta. ठीक है ना? This will be delta beta. So this will be the extra path that is introduced by this. Now, this is S2P minus S1P minus mu minus 1 into T. Just before in this lecture, in the starting, I have, from the geometry, I find out this value. S2P minus S1P, either you are introducing glass plate or not, but that geometry is still applicable. So what will be S2P minus S1P? In that geometry, mu was not involved. So from that geometry, this was equal to how much? This was X small d by capital D. ठीक है ना? This was minus mu minus 1 into T. Mu minus 1 into T, and this will be delta. So what is this X? X D upon D. This will be equal to, कितना होगा बेटा ये? Delta plus mu minus 1 into T. Mu minus 1 into T. This will be. So this X, this will be capital D by small d, and this will be delta plus mu minus 1 into T. That is this one. ठीक है ना? It will be this one. Now, what is the condition of nth maxima? Condition of nth maxima, you know that delta part difference, this part difference, ठीक है ना? This part difference at point P, it should be equal to n lambda for maxima. For maxima. For bright fringe or maxima. Maximas, they are called as bright fringe. Minimas, they are called as dark fringes. So for maxima, delta will be this one. Substitute this delta here. So what will be X? X will be capital D upon small d. Capital, and this will be n lambda plus this will be mu minus 1 into T. That will be this one. ठीक है? So where was n equal to 0 fringe? ठीक है ना, when there was no glass plate. Remember this, you are having that fringe here. So in the absence of glass plate, this was the position of the central maxima. Now where will be the position of the central maxima? So I'm writing here new position of the central maxima. New position of the central maxima. Central maxima, that will be x naught. So central maxima is corresponding to n equal to 0. 0. So this x naught, position of the central maxima, this will be 0 here. So this will be d by d. ठीक है, and this will be mu minus 1 into t. So this will be the new position of the central maximum. So what will happen? This was earlier position and this is new position and this is new position of n equal to 0. So this shift is going to take place. ठीक है ना? Central maxima will shift in the upward direction if glass plate is introduced in front of S1 because this is a positive quantity. Because this is a positive quantity. If you are introducing glass plate here, if you are introducing a glass plate here, then remember this mu minus 1t will be with S2p. In that case, you are going to get a minus sign here, and this x naught will be with minus sign. So if you are introducing glass plate in front of S2 in place of S1, then shift will be in the downward direction. So your pattern, interference pattern will shift in the upward direction. ठीक है ना, in the upward direction. By what distance? By a distance equal to x naught. X naught. And this x naught is how much? This is d by d and mu minus 1. Mu minus 1. Every fringe is going to shift by the same. ठीक है ना, try to understand. If you are saying this is the position of nth, what is the position of n plus 1th? Or new position, this is the new position of not n plus 1th. You observe this is the new position of nth maxima. ठीक है, if you are introducing n lambda here, what was the old position? Old position was d by d. ठीक है, and this will be n lambda only. This was equal to n lambda only when there was no glass plate. If you take the difference of these two, this will be, if I write here xn prime minus xn, then you will find out it is again x naught. ठीक है ना, this will be again d by d mu minus 1 into t, or I write here d by d and this will be mu minus 1 into t. Mu minus. So remember this the separation or the shift, not separation, the shift in the position of nth maximum is independent of small n. Small n is not appearing here. It means all the fringes, they are shifted in the upward direction by the same distance. So you can write here, it means after this, you can write, it means all the maximas are shifted, all the maximas are shifted in the upward direction. All the maximas are shifted in the upward direction by a distance x naught, equal to d by d mu minus 1 into t. D by d, capital D by small d, mu minus 1 into t. Capital D by d, mu minus 1 into t. So they are all shifted in the upward direction by this distance. In the next line, please write, if glass plate is introduced in place or in front of S2. If glass plate is introduced in front of slit S2, S2, in front of slit S2, in front of slit S2, then then all the fringes will shift in the downward direction. Then all the fringes will shift in the downward direction. So you please write these points as 1 and 2. Okay? In first point, basically all the fringes were shifted in the upward direction. In second, all the fringes are shifted in the downward direction. Now, can you tell me what will happen if you are introducing two glass plates like this? This is of thickness T1, this is mu1, this is of thickness T2, refractive index is mu2. Then what is going to happen in this case? In this case, this x naught will be equal to how much? Try to understand. When you are introducing glass plate here, you are getting here mu1 minus 1 into T1. When you are introducing second glass plate, then that will be here S2P plus mu2 minus 1 into T. And when you will do all the calculation, your x naught, in that case, x naught, it will be equal to capital D upon small d, and this will be mu1 minus 1 due to the upper one, the slit in front of S1 into T1. Okay, minus with minus sign it will be due to second glass plate in front of S2. This will be mu2 minus 1 into T2. Okay. Now pattern will shift in the upward direction or downward direction. It depends upon who is introducing more extra path. If first glass plate is introducing extra path, if this is greater than this, if first glass plate is introducing more extra path, then this number will be greater than this. Automatically pattern will shift in the upward direction. So what I'm writing here, if mu1 minus 1 into T1, this is the extra path introduced by the first glass plate in front of S1. If this is greater than this mu2 minus 1 into T2. T2 I'm writing here first. Then x naught will be positive. So what is meaning? All the fringes.
Hello, sir.
Yes, beta.
Sir, previous slide, please.
Just 1 second, beta. All the fringes will shift in the upward direction. This is very similar case, first case, when you have introduced a glass plate in front of S1. So all the fringes were shifted in the upward direction. Now here in front of both the slits, you have glass plates, but first glass plate in front of S1, that is introducing more extra path. So automatically this is greater than this. So this x naught will be positive. All the fringes are shifted in the upward direction. Now second, suppose this mu1 minus 1 into T1, this is less. Okay? More extra path is introduced by the second plate in front of S2. In this case, this number is greater. So this x naught, that will be negative. And all the fringes will shift in the downward direction. All the fringes will shift in the downward direction. in the downward direction. ठीक है, third case may be there if they are both equal. Whatever extra path is introduced by one, same extra path is introduced by two. Third case may be mu1 minus 1 into t1, that is suppose equal to mu2. You can get a numerical on this t2, this condition. This is an important condition. If both are introducing exactly equal extra path, then x naught will be 0. So pattern will not shift. Means interference pattern will not shift. Pattern will not shift. So here interference pattern is not going to be shifted. ठीक है, this was another case related to Young's double slit experiment. Is it clear up to this point? Okay, I will show you earlier slide. This was, so please note it down. This is earlier one. Okay. Next. Can I go to the next slide?
Yes, sir.
This is next one. Please note it. Now, another aspect of the interference pattern. Suppose I'm having two slits here. Try to understand. I'm saying one slit is here, light source, you can say. You can say slit or coherent sources. I'm saying two coherent sources, S1 is here, S2 is here. Okay, before that, can you tell me one more thing? Okay, can you tell me one more thing? This is my source. This is also important. I'm having two slits here. This is S1, S2, S1, S2. We are having a screen here. We are having a screen here. This is screen. ठीक है, you are getting pattern here. What will be the shape of fringes? ठीक है, question is what will be the shape of fringes? What will be the shape of fringes? बोलो. Shape of fringes. ठीक है. You are going to get me the shape of the fringes and you have to tell me the reason. बोलो बेटा. What will be the shape of fringes? Anyone? And why?
Like,
Hyperbola.
Why? Why it will be hyperbola?
there will be a one form which will have the same path difference.
Yes. So
Circle.
try to understand. Okay. ठीक है. What is the definition? How you define a parabola? Sorry, hyperbola. बोलो बेटा. So if you remember from your class 12, you can say hyperbola is something like this. this type of. And here this is S1, you can say this is S2. Okay, so hyperbola, what will be the hyperbola? Hyperbola will be the path of a point P. Okay, path of a point P. What will be hyperbola? Hyperbola will be a path of point P which is satisfying this condition that S1P or S2P minus S1P, and it will be constant. Means suppose you are having a point P here or here, then this difference. Okay, it will be. So S2P minus S1P. So you can move from here to here. Okay, now this equation is going to be satisfied. This equation is called as the equation for the hyperbola. And if you are having nth fringe here, what is the condition of nth fringe? What is the condition of nth fringe? Condition of nth fringe, nth maxima, nth bright fringe. Yes, beta?
S2P minus S1P
Yes,
will be
beta.
NVS.
Correct, beta. That is S2P. ठीक है ना? This will be S2P here. This will be P. And this will be S1P. So equation is this S2P minus S1P. And that will be n lambda. N is a constant for the nth bright fringe. N will be a constant. Lambda will be a constant. So you can say this is a constant. So you are saying that you are going to get the condition of nth maxima satisfied on the screen. You are having a screen, and at all those points where this condition is satisfied, you will get the nth maximum. Okay? So you are saying on this screen, at every point where this condition is satisfied, you are going to get nth maxima. Okay? You will find out this number that will be a constant. It means what type of shape on this screen you should observe for the maxima, that should be hyperboloid. ठीक है ना? That will be this type of hyperboloid. But actually you know that you can place this screen here, 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 or anywhere. These are non-localized fringes. So what will be the shape of the fringes? Actually, you have to rotate this. ठीक है ना? You are going to rotate this. Please try to understand on the screen. ठीक है ना? On the screen, if you look at the screen from the front, from this side, if you are standing on this side and you are observing these, then your fringes, this will be the center here. This will be the center here. And your fringes will be like this. Your fringes will be like this. You are going to have fringes like this. This type of hyperbola you are going to get. So shape of the fringes, ठीक है ना? Nth order maxima, first order maxima, second order maxima, they will be hyperboloid of revolution. If you are revolving these, ठीक है ना? If you rotate these like this, ठीक है? Or like you are going to rotate like this in this way, then you are going to get hyperboloid of revolution. So what type of shape of fringes will be hyperboloid? Hyperboloid 3D structure. In 2D it will be hyperbola, hyperboloid of revolution. For 3D it is. This will be the shape. Revolution. In 3D. This will be. But if you look, if you have performed this experiment in laboratory, what you are finding that you are just observing straight lines. Why you are observing a straight line? Because try to understand this number, this lambda, ठीक है ना? This is light, visible light. ठीक है. So you are around 4-5,000 angstrom. This is a very very small quantity. ठीक है. So this constant is very very small. So your hyperbolas, they will be something more or less like this. Your hyperbola will be like this because this quantity lambda is very very small. And on the screen you observe only a very small part here. A very small part of these fringes you are going to observe. So that's why you observe only straight line fringes. When you are performing experiment, you observe that these fringes, they are straight line fringes, but they are not. Actually, they are a part of hyperbola in 2D. And if in 3D you look at it at, that will be hyperboloid of revolution. ठीक है ना? So that is the shape of these. Now, next, is it clear to everyone?
Yes, sir.
Next, beta. Actually, ये जो fringes हैं, they are distributed in 3D. In all these space, these fringes are spreaded. They are not localized to any particular plane. So, shape of these fringes will be a 3D structure. So that 3D structure will be this. 2D structure, that will be a hyperbola. ठीक है. If you are looking just on this screen, then that will be a hyperbola. And if you are looking at for 3D structures, 3D shape of these fringes, they will be hyperboloid of revolution. ठीक है. Next. Suppose you are having this source S1 and you are having another source here. This is S1. This is S2. ठीक है. This is S1. This is S2. Now, I place a screen here. ठीक है. What I do? I place a screen in front of these two. This is here I place the screen. If I place the screen here, what type of fringes you are going to observe? You are going to observe because they are in front of, screen is in front of these S1 and S2. Then you are going to observe here hyperbolas. Shape of the fringes will be hyperbola, or you can say straight line for the experimental purpose. But actual shape is hyperbola if your screen is here. Now what I do? I remove this and I'm saying I have placed a screen here. I place the screen here. So what is this blue line representing? This is blue line is representing the plane of the slits. What is this? This is plane of slits. Plane of slits. And what is this? This is screen. Screen. And this is the center of the screen, you can say. ठीक है. Or just wait for 1 minute. I will make much better screen here. Suppose your screen is something like this. Suppose we are having a screen like this. You are having this screen. Now, can you tell me what type of fringes you are going to get? This screen is perpendicular to this plane of slit. Screen and slit plane, they are perpendicular to each other. So this is screen.
Here,
Yes, beta, it will be circles. Fringes will be circles. The reason is, try to understand where you are going to get maxima. Suppose nth order maxima you are talking about. What is the condition of nth order maxima? That will be S1P. Suppose P is the point for the nth order maxima minus S2P. And this should be equal to n lambda. So this will be a constant number. Suppose at this point you are getting, suppose this is a point P where this condition is satisfied. So this will be, this is S2P. This will be S1P. This is one of the point where this condition is satisfied. So what will be the locus of the points which are satisfying this condition? So shape of the nth order maxima will be decided by the locus of points which are satisfying this condition. And where these points will be, they will be on the circumference of this circle. So here there will be a circle. Radius of this circle is this one. I call this point is O. So by choosing this OP as the radius, draw a circle on this screen. So at every point, you can choose a point, any point from here on the circumference of this circle. This S1P minus S2P will be equal to this. So every point on the circumference of this circle is satisfying the condition of nth maxima. So every point is actually satisfying the condition of nth maxima. So this circular form will be the shape of the nth order bright fringe. So this will be the nth order bright fringe, nth order bright ring. So shape will be circular. Okay, here shape of the fringes will be circular. Okay, this will be the shape of the fringes. So basically every point on this screen which is satisfying this condition will be the locus of nth maxima. So it will be a circle. If you are having fourth order maxima, you want to find out right here 4, that will be a constant. Draw a circle corresponding to that. For n equal to 3, there will be a different circle. For n equal to 100, there will be a different circle. So these fringes, they will be in the form of circular rings on the screen. Okay? So shape will be circular beta here. So for today, I am stopping. In the next class, we will continue from here. In the next class, I will discuss first interference due to n number of slits. And then I will discuss thin film interference. Okay, in between I will take some numericals, 5 to 10 numericals I will discuss related to whatever I have discussed up to this point. And then I will move to thin film interference. After thin film interference, I will discuss Michelson interferometer. Okay.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.
Thank